Good evening, everyone. Lovely to see all of you here today. I hope you are all having a great weekend and are looking forward to hopefully a relaxing Sunday ahead. How many of you have relaxing Sundays coming up? Please raise your hands. Wait, many of you. Okay, some people are half. Some people are no relaxing Sundays at all. Okay, please work on things. Make Sunday relaxing. That's the point of Sunday. Okay. However, if every day is relaxing and you're only choosing to work tomorrow, that's okay. I grant you the ability to work. Okay. So, uh, I'm Siddharth. I'm one of the community leads at Gifted World. Many of you, uh, many of you have seen us over the past year and a half that we've been running programs. We are a community that's dedicated to helping gifted and talented students reach their full potential. We're a partnership formed by the Center for Talent Development at Northwestern University in Chicago, educational initiatives, that is the creators of the ASSET diagnostic tests, and GenWise. We are running a really fun summer program that's happening in July. Some of you are already a part of it. And as part of that summer program, we're having a course that's aimed for students in grades 5 and 6 on algebra. And we don't teach algebra the normal way. Like we actually barely teach anything the normal way in Gifted World. We like learning through fun and learning through curiosity. Okay. So we believe that when you do it that way, you can learn how to explore and continue exploring yourself. So with that, I'll talk a little bit more about the upcoming course at the end of today's session. But first, I would like to introduce our mentor for today. Vidya Govindan is the founder of the Growing Young Mathematicians Foundation, which is based in Chennai. She is a very passionate mathematics educator, and she focuses on problem solving skills and systematic thinking. So she is very much aligned with how we like to view the world in terms of learning. And we're very excited to have Vidya running today's session, which is just a couple of adventures in algebra. We encourage all of you to keep an open mind, be curious, okay? And I'll be helping moderate the discussion, right? So you can keep putting questions in the chat and I'll make sure we get it to Vidya. And a request that we're a small group of people, so I'm not going to mute everyone, right? Feel free to raise your hand in case you want to say something, and then I will request you to unmute, just so that we don't talk about each other. Okay? Thank you all. Let's be kind and respectful to each other, and let's have a fun time learning. Now over to Vidya. Thank you so much for coming here today, Vidya.
Yeah, hi, children. I'm very glad to see such enthusiastic children from across the globe. And it is so, every time I talk to children and taking these sessions, I really enjoy myself based on their interesting, the way they think with interesting questions. And I'm sure today we also going to have a wonderful fun time, which will make you kind of see things around you in a different lens, in a different perspective. So that can I share my screen?
Sure, I'll just make you a co-host. Sorry.
Yeah. Okay. Okay. So I hope you are all able to see my screen now.
Yes, we can see your screen.
Okay. Just I think it has another screen. Yeah. Okay, so like Siddharth has already mentioned, we are going to see things differently in an algebraic thinking and algebraic lens, right? So that's why this is called an algebraic adventures, wherein we are going to explore algebra in a really different way. Yeah, and feel free to have it as an interactive participation because that is how it has been designed to. So, yeah, so today's agenda is introducing you to a new thinking routine called notice, wonder, and think. So it's a very interesting routine that many of the mathematicians use themselves to kind of understand the world around us in their own way. Yeah. And then we are going to use some pictures and patterns to explore algebra using this notice, wonder, think routine. And then finally, we are going to have a game of unknowns. And that's why you're all having the bowls with different colors and the beads or grains. So this is going to be the agenda for today. And I hope you all see these images around you, right? Everywhere. You see wonderful images. They are not random, some are random, but then some are having these kind of interesting patterns within themselves, hiding behind, isn't it? Yeah. So this is one such pattern which you see in most of the vegetable markets. Patterns like this have very interesting things inside it, right? For these patterns, you can see the shapes. In these patterns, you can see the arrangement. And this again, kind of a tile where you see a different geometry hiding behind these pictures, right? So these are everyday pictures, isn't it? Yeah, that you see and you pass by. But then what does the mathematicians do, even in their young age, is they follow this routine. Notice, wonder, and think. So what does notice mean? Notice mean basically is to observe. Is there something different in it? What kind of things I can see? For example, let's take this picture. Can any of you tell me what do you notice in this picture? And anything that you see in this picture? Yeah, Anusha, if I am right. Yeah,
Anoushka.
Anusha. Anushka, yeah.
Ma'am, I noticed that in the center,
Mm.
all the stairs are lined with some green paint,
Mm-hmm.
but on the sides they're lined with red paint.
Okay. Yeah. So that's kind of already a pattern. Like between two reds, there is one green. Yeah.
And
Thank you, Anushka. Yeah. Yeah. Continue, Anushka. Yeah.
and there are two like snake-like things on the sides.
On the sides. Yeah. Okay. Good. Yeah. And yeah, Harshita. Yeah,
Yes,
Harshita.
ma'am. Uh, I can see in the middle there is it's really bright, whereas towards the sides it's more dimmer.
Ah, yes. The light also is kind of varying. Yes. Good observation. Yeah, Aaron and then Ivan.
Also there's perspective, so like
Hmm.
the higher in the picture you look on the rails,
Ah.
it's converging down to the 0 point.
Yes, exactly. So it is not exactly straight, which means it is showing the depth, right? So the steps are slowly diminishing, and towards the end, it is almost very close. Yeah. Thank you, Ivan.
Yes.
Yeah, Ivan.
Actually, even I wanted to say the same thing, that it's getting closer and closer at the end.
At the
Like it
end, yeah.
appears like that. But also, what I noticed is on the side, there's something which looks like a snake.
Uh-huh.
It's that on the left side, the part facing the stairs is green and the part facing the trees is gold, but on the
Gold.
other side, it just vice versa.
Okay, so you are finding already a pattern on the snakes. Yeah, good. So I see many raising hands. So we are just going ahead and then you can participate in the discussion. Yeah. So this is actually noticing the structure, noticing the shape, noticing the colors. And then what about wonder? It is about asking questions. For example, I see the steps are going and then kind of going at the end in small gaps. But if I think how many steps there could be based on the dimension that it is showing in the picture, how many steps could it be there? And what could be the length of the rail if this is the steps? So if the step size is kind of, some centimeters, what could be the entire step size? So these are kind of the wonder questions that usually mathematicians ask. And they don't stop with the wonder questions, they go ahead and pursue it. Meaning, they kind of think, okay, so if I see that this is the depth of this picture And if one step is approximately around, some 20 centimeters, I think based on the depth, it could vary these small, like with a ratio, it is actually going down in this kind of a decreasing pattern. So this is how they come up with different solutions. So I'm just introducing now what does notice, wonder and think mean. Yeah, this is the thinking routine and we are going to use it. So these pictures that I show you are different pictures that around you, and we are going to use a kind of two important pictures where you see very interesting patterns, and then we are going to apply this routine. Yeah, so sorry that I cannot give chances for everyone, but we are going to engage in a different picture altogether. Yeah, so I hope all of you are able to understand the notice, wonder and think routine, right? So we will proceed further, and you are open to do any observations like you already mentioned. It can be crazy, unclear, good, interesting, doubtful, anything is fine. So we are just going to have an interactive discussion here, and based on a picture, right? So I will just share another screen now for us to proceed further. Yeah. Okay, so I hope you're able to see now, right? Yeah. Okay, so here it is, the picture that we are going to work on. Yeah. So now let's take 2 minutes, have a close look at the picture. Maybe you can just quickly jot it down, your observations, and I will also write down your observations once you're ready. Yeah, that should be fine. Okay, so now closely observe and jot it down. What is your observations from this picture? If you get stuck, don't worry. I'm going to give you some guiding questions, but I want you all to sharpen your eyes. And if you want me to have this picture a bit zoom, I can do it. So we'll just wait for 1 more minute and then I'll note down your inputs. Okay. So maybe I'll just start making, if someone has some observations. So I'm on a different screen, so feel free to, share your observations. Yeah. Any of you have some interesting observations from this picture?
The further away you go, this is the Louvre in Paris, and the further away you go, meaning the further away you look, the smaller the smaller everything is.
Okay, so further up makes the, I can say the square tiles, right? Square tiles look small.
Yes, and also
Yeah.
square tiles, they look like they're rhombuses.
Okay, so you see that it's a rhombus. Okay, is the square tile itself is rhombus, or does it arranged to form a rhombus?
No, so the square tiles, they look like rhombuses because of the curve of the pyramid from this angle.
Okay.
And they are arranged into rhombuses, and
Okay.
they're actually just perfect squares.
Okay. Yeah, and also the perfect squares. Like for example, if you see here, I'll just mark it down. Yeah, so I think this one, right? This one is a rhombus. Yeah. Okay.
Ma'am, the struts supporting the building, like they are arranged in a triangular pattern. Like a few of these squares are cut in half to make a triangular pattern.
Oh, okay. Yeah, that's so the arrangement also looks like a arrangement
Ma'am,
is made of
a
triangle.
triangle inside a pyramid, ma'am.
Okay.
Main triangle.
And
So
this
is it like a
square
triangles inside a pyramid, or the pyramid is made of many triangles?
Ma'am, the pyramid itself is made up of 4 triangles.
Yeah, okay. So I can write it down like pyramid is made
Ma'am.
of triangles. Yeah. Yes.
Ma'am,
Yes,
and I can notice that. Ma'am, I can notice that there are intersecting lines.
Intercepting lines. Which one do you, can you just, I have this intonation here. Which one do you think is actually intercepting line? So is it this one here? This one?
Yeah, and the lines, the horizontal lines and the lines which are vertical, they're connecting. Yeah.
Okay. Yeah. Okay.
ma'am.
Yes.
Ma'am, I have a few observations that if you look at it, ma'am, can you move a little so that the entire picture comes?
Just a minute. I'll switch off this annotation. Yeah. So intercepting lines. Yeah. Okay. Yeah.
Ma'am?
Yes.
Yes.
Hmm.
So, ma'am, if you can see from this angle, this entire structure looks like the first layer looks like a triangle that has been intercepted, right?
Okay.
But if you look closely, if you can see this, the edge that it touches the ground, it might look like the triangle surface is facing us, but
Yeah.
then the structure could be bent.
Yes. So basically the entire thing can be seen as a triangle, right? Okay. So now I'm just going to give you some guiding questions here.
The
Yeah.
first one. There seems to be a triangle overlapping the first one.
Where do you see a triangle getting overlapped here?
Behind the main structure, you can see
Oh, okay. This one you are referring to. The one here. The one,
it seems as if it is overlapping one.
this
Like
one?
a shadow. It's kind of like making it look like 3D.
Okay. Yeah. That looks like a 3D. Yes, that's right. Okay.
And ma'am, there is a cubical structure that looks as if it is supported by the edge of this overlapping triangle Angel said. It looks like as if it is entirely sitting on the edge. No support otherwise.
Okay. So this cubic structure is actually sitting on the vertex, like on the top, right? Edge would actually mean the side, but then on the top vertex. Yeah. Okay, good observation. So I'm just going to slightly guide you with some questions that could also be interesting. Yeah. In this case, you have observed that there are triangles here, right? Have you wondered in this triangles how the square tiles are related? Let me erase this. How the square tiles are related to the triangles, and what kind of triangle do you think this is?
Miss, this is a square base pyramid.
Yeah, but then I'm asking about the triangle here, the triangle that you all have been talking about.
Equilateral triangle. Ma'am,
Okay. How many of you
Ma'am,
say that
I
this is an equilateral triangle?
Ma'am,
This-
I think it's an isosceles triangle.
Okay, so whenever you say something, please do tell why or how you are telling it so. Like if it is a equilateral, how do you tell it is an equilateral, or is an isosceles? How do you say so?
two isosceles triangles will form a parallelogram, and two equilateral triangles will form a rhombus. That's a parallelogram, not a rhombus.
That's a good observation, right? So this is a parallelogram in here. Okay, let me show you the, yeah. So where do you see the parallelogram? Is it this one? I'll show it in a different color, maybe a red. Yeah. So is it this one, the parallelogram? Yeah.
From
Yes.
there, and the angle, two angles are equal, and one angle they seem to be acute, and the angle at the top seems to be either a right angle or an obtuse angle.
Okay, so now I have a question to you. So the angles are, isn't it a bit of approximation that you kind of think that these are same and the opposite are same?
Yes.
But is there another way where I can say it for sure that okay, this is isosceles? Is there some other clues here?
Yes,
That you already, yeah.
Yes, the tiles are square, and if you look at the tiles, you can see that it's a right angle.
Okay, so the
That's a
right
right angle over
angle,
there.
yeah, that is a right angle, yes. And besides that, based on a right angle isosceles or a right angle, I have given you here already.
And yes, and also the length and the height.
Yes. So that's a good point, right? So if you count this one, two,
Yeah, that the
3, 4,
diagonal, the
5,
side.
6. Yeah, 1, 2, 3, 4, 5, and 6. So
That'll be
this can be
square
a,
root of 2 by 6.
yeah, exactly. So this is basically a right angle
two sides
isosceles
are equal.
triangle. Yeah, two sides are equal. So these two sides are equal and this forms a right angle triangle and this is a right angled isosceles triangle, right? Okay, good. So with this, this is a wonderful observation that all of us have made. So if I can ask you to kind of ask some second point about wonder questions. What kind of wonder questions you can ask based on these observations? I actually showed you, told you about what is a wonder question. So assume that we have been talking about, parallelogram and a right angle isosceles triangle. What kind of wonder question you can ask? You can also think yourself like, you are the designer of this building. So what would you think if you observe this pattern?
How big is it?
How big is it? Okay. What does it mean when you say how big is it? It's an open question, right? So
What's the height? What's
yes, exactly. Let
What
me
is
actually
mass?
take a minute.
What's the volume?
Let me
How would you support the structure with the frame?
Take turns. Hi. So there are a lot of us, and I know we're wondering about a lot of things, but let's please take turns so that we're not speaking over each other. Okay. And yeah, so thank you to those of you who are raising hands. I'll just take the time to call on you. Vidya, is that okay? Or
Yeah, sure. Yeah. I can't see them talking because I'm on a different window. So
right. No worries. Rajveer, your hand was up.
Yes, ma'am, I think maybe that you had mentioned this. How are the triangles in this shape and the squares related?
yes. So can we build upon that? So how are the triangles?
Ma'am, sorry, ma'am, you can continue.
Yeah, how are the triangles and squares are related? That's a very good question. Yes.
Ma'am, can I ask?
So right now we're just putting down questions, right, Vidya? We don't want,
Yes.
don't want them to answer the questions. Just.
No need to answer. We will just jot down all the questions and then in the thinking routine, we will try to see what concept to apply and find answer. Yeah.
Arnav?
Yes. My wonder question is that if what is the purpose of putting these intersecting lines? Like, how does this help the architecture and this? And also that you see the triangle that's being overlapped behind. Yes.
Yeah.
So what is the purpose of that? And how does that support the box on the top?
Okay. What is the purpose of the overlapping triangle and how does it support the cube? Right? Okay. I think you have now started thinking like a real designer. Okay. Fine. Let's apply some kind of thinking related to the shapes and the numbers here. You can also think about the parallelogram, right? So you can think about parallelogram or any other shapes that you see here.
What kind of
Krishna?
May I answer?
I was going to make this and I would think of the rooms inside and if I would align the triangles with the rooms. So for example, each triangle would be a room or the intersecting lines would be the terrace, would be the ceiling or the floor of a room. So
Okay.
try to see if the rooms connect with the outside design.
Okay. So how does the intersecting lines relate to the
inside the room?
Interior, yeah. Inside a structure, maybe the roofs. And what was your another point? Yeah, the square tiles are the rooms, right? That was another very good question. If the square tiles are the rooms, maybe you could ask this question, right? How many rooms it can accommodate? Yeah.
How many square tiles are there? You're asking?
Yeah. So basically, if she thinks that the square tiles are actually forming a room inside, so on that case, how many rooms it can accommodate? Like it can build in a single isosceles triangle or in the entire structure. So as we go build the structure, but basically she thinks that I think it's if the square tiles are the rooms, how many rooms it can accommodate, like inside the entire building.
Well, not one
So
tile.
we'll have one more question. We'll have one more question, and then we'll go to the
Ma'am,
think routine. Yeah,
ma'am,
please.
I have a question.
Yes.
How is the from this viewpoint in the left side we can see that the squares are looking like the squares, whereas through to the right side we can see it's more of a rhombus shape. So how is that like illusion made?
Okay. So what is the perspective? What is the perspective that gives the square tiles a rhombus view, right? Like based on the architecture. So it is based on the angle that is being joined, which is giving them a different perspective. Okay. I think we can stop here. We have very good number of questions now. Let's go to the think routine. Yeah. So if I can say start with the second question, because that forms a very important basic question for us to, use this think routine well. How are the triangles and squares are related? So for
The
example,
triangles and squares are related because the two triangles make one square. So the sides of the triangle could be a half a square.
I think are you referring this as a square? This one as a square?
No, they are only half of a square. They are not completely.
Okay, so are you referring to this square tiles as the square now?
Yes.
Okay, yeah. So if this square tiles you are referring to, how this and the triangle is related? How do you think they are related? Can you see? I can also show you another triangle here, which is a bit smaller. Have you observed this triangle, which is a bit smaller here? Yeah. So can you all think now? How are these squares and the triangle are related?
Miss, because squares are uniform, so they act as a measuring tool.
Wonderful. So if you can measure with squares as a measuring unit and the triangle as a structure built from the square, what question you can think of? Can you think of the question which someone I think has asked here?
Ma'am, in the middle there are full squares, and on the edges of the triangle there are only half squares.
Exactly. So maybe you can consider that the two half squares will make up as one square. And can we ask this question? How many square tiles would be needed to make this single isosceles right angle triangle? Yeah.
Yes.
Can you all try finding it out? How many isosceles triangles? So how many square tiles?
Squares of triangle will be required for creating the squares, half squares.
Okay, yeah, you can consider that these two small triangles.
36.
These two small triangles make up a square. So you can count this as a square. Okay,
Ma'am,
anyway, you need a square.
36, ma'am.
Yeah, good. So just a
36.
minute, yeah. So I'm going to ask you another question now. So you consider these two triangles and then it is also considered as one square, right? And 36, may I know anyone, did you really count?
Yes, ma'am.
Count from, okay. So if you count, yeah, then you say like, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then these two make 11. Right, so it is 11. And what is in the second row? If I consider this as the first row, in the second row, it will be I can change it to maybe black. Yeah. How many in the second row?
8.
Is it 8? What about the two triangles?
So 9.
It's 9. How many do you think in the third row?
7.
7. Okay. And then the fourth row?
3.
3.
No, sorry, 5. 5. 5.
Okay. 5. Yeah.
Then 3.
And
then finally there's 1 in the top.
1. Okay. So you all counted, right? Really 11, 9, 7, 5, 3, 1. Do you think this counting is a bit better approach? Like if you have very big triangle, do you think you can
No,
keep
ma'am.
counting? No.
No, ma'am.
What do you think you can do in this case?
You just count the bottom row, and then if it's equilateral, then you can just remove 2 each step of the way.
Okay, but this is not equilateral.
Ma'am,
Yeah.
I think since all of them are made out of the same like square, I mean the same triangle size.
Yes. Yes.
Like so then maybe we can count how many such big triangles there are, and we can multiply it with 36.
Oh, okay. Yeah, that's a good point. But then, okay, assume that, you have such a big structure, not made with, small triangle, but then you have a long, like instead of having 11 here on the base, if you have something around 50 in the base, let's take 50 or any number, big number. So you will try to form smaller triangles and then try to multiply, right? That's what, for example, let's take here this one. So where you see 1, 2, 3, 4 and then 5, right? So 5 plus 1, 2 and then 3, 3 plus 1. But then with this, will you be able to make this big triangle?
Ma'am,
No.
No, you cannot, right? But then with equilateral triangle, you are right, Harshita, that you can make based on the smaller equilateral triangles. But from here, you cannot. For this, let's observe this picture in a different way. Okay, I'll give you some kind of a guiding points for you to think. So someone told that this is a wonderful parallelogram, isn't it? Can you think how you can use that parallelogram idea to count the triangles, like the squares, number of squares needed? Yeah. So this is the actual parallelogram, and you know how this parallelogram is made basically. How this parallelogram can be made. If you, for example, let's label it, okay, for our easy naming. If I label A, B and C, okay, I have this right angled isosceles triangle A, B and C. If I want to make a parallelogram, how would I arrange it? Like I'm going to use a different color. Assume that you have this exact piece which you're going to use and make a parallelogram. Yeah. So how would you name it? So like I have this another triangle here. Which one will point to A? Or let's say the point C is different, right? So which one will point to C? Which of these? So this is the second triangle and it has 3 vertices. So this is the first triangle. I have marked ABC. In the second triangle, where do you mark A, B or C? So where do you
C
put
C and B will be the same, I believe.
Okay, C you want to put it here, right? Why?
Because you're flipping it upside down.
Exactly. You're flipping it upside down. There are 2 triangles here, 2 triangles here. So you can make it a C. And you can make A and B anything,
B.
isn't it? Yeah, A and B is anything. You can have A and B. Yeah, okay. Now, you know that it forms a parallelogram. And now think it from a number perspective. Yeah, we are trying to add these numbers 11, 9, 7, 5, 3, 1. You are just now using 2 of these triangles which forms a parallelogram.
You multiply by 2.
Yes, but then you don't know this first area of this area or the number of square tiles you need for this right angled isosceles triangle, because you know that it adds up to 11 plus 9 plus 7 plus 5 plus 3 plus 1. But then you are trying to find some smarter way to add this. Yeah, can you pay a close attention here how these parallelogram is formed based on the number of square tiles?
Ma'am, you invert it like
Ah.
so 11 plus 1, 9 plus
Hmm.
3,
Okay.
7 plus 5.
Wonderful. Yes. 11 plus 1, right? There is 2, which forms one triangle here. So if I write this ABC inverted triangle number, the first row, okay, let's do it like this way, right? The first row, second row, third row, fourth row, and fifth row. Yeah, this would be a better way to record our ideas. And in the triangle on the left side, it is from 11, 9, 7, 5, 3, 1. And the triangle on the right side, it is how many? 1.
1,
Here
3,
it is 3,
5, 7, 9, 11.
11. And how can you use this for our original question?
Ma'am, all of them add up to 12.
Wonderful. All of them add up to 12. And how many 12s? How to find how many
5.
12?
Sorry, 6.
Sorry, I did not put 6. Okay. So how
So
many
12,
tiles needed for the
72.
parallelogram? 72.
72.
But then are we worried about parallelogram? What
No,
was our main
72
question?
divided by 2.
Why?
Because there are two triangles make one parallelogram. So to find the area of one, you have to divide by 2.
Exactly. So you get 36. Right? So basically, we have found a different way to find how many squares needed to form this isosceles triangle, isn't it? So, for example, you all in the initial days you all counted how many are needed. But let's say, for example, if I am having instead of having 11 plus 9 plus 7, if I am having, let's say, 21 plus 19 plus 17, like that, which means, okay, before going to that question, I think we need to understand how these this length, like the base and the height, are related. Okay, this is a very good question, and then we found the answer for this question. Now moving on to the next question, if we can see, someone was telling about the height here, right? Yeah, the first question actually about the height. How do you think the height and the base are related? So for example, if you know that the base is needing 11 squares.
The base
And
is
the height is 6.5. Sorry, 5.5.
Is it 5.5?
base of the loop
1,
is
2, 3, 4,
2
5,
meters long.
5.5.
Okay, let me write
Technically, it's 5.5, but 5.5 is the
1.
same thing.
See, 1. Okay, 1, 2, 3, 4, 5. And is it a half of a square?
Yes.
Is it half of a square? Okay, see, I'm just doing this. I'm just drawing this here. Do you think this height is half of a square?
No.
It is actually two triangles that make up a square. But this height, is it half of a, like the height, isn't it same? The side?
Oh,
Basically, if you think that this is
so it's
made
6
of,
squares.
if this is made of 11 squares, and if I use that as a base is 11 square, right? Square side units, I can say. Square side units. What is the height?
6.
What is the height? It is
6.
6. And that is why we had how many rows?
6.
6 rows. So if you find the base, number of square tiles on the base, is it possible to find the height?
Yes.
Yes. How do we do it?
The width of the base, the length of the base is 12, even though the area is only 11.
Okay, actually, yes. So this entire thing is 10, and then if you add the square, so if I say the side of the square is 1 centimeter, what is the base then?
12 centimeter.
Will it be 12? Can we think again? So assume, okay, so
1, 2, 3, 4,
yeah,
5, 6, 7, 8, 9, 10, 11, 12. Because the
yeah.
bottom
So
is the same size.
exactly. So then what is the height?
Wait, ma'am. If it's 12
1,
and
2,
the
3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So this is 12 and the height is 1, 2, 3, 4, 5, 6. So the height is 6.
Is-
So for any triangle, if you know now the base, based on this pattern, you will know the height, isn't it? Yeah. So do you think that observing this pattern and coming up with this generalization meaning how do you use this structure to make up bigger structures or any structures made with the same pattern? So for example, if I want to find a similar isosceles right angle triangle with a base made of 50 square sides, right? With a base made of 50 square side, meaning there are, this base is 50. Okay. So would you be able to find the height? Yes. Would you be able to find the height? Yes or no?
25.
Yes. It should be 25 if it follows the same rule. And would you be able to find how many square tiles are needed?
Yes.
How many?
It'll be
It
so
will be
it'll be that 49 squares for the bottom.
okay. So you can actually think from our existing example also. So you had 12 and 6. And then the number of square tiles needed is 32. How are they related? How are
You
they
can just
basically?
scale up. You can just scale up.
Yeah, scale up and what would be the tiles needed then? So here what did we do? We did 12 into 6 times, right? 12 into 6 times and then divide by 2, which is 36. So we understood from the geometry shape perspective, from the parallelogram, how to add easily, how to get the 12 repetitively and then found out based on the parallelogram. And next, we also found out based on the number of square sides and the height. We found out in 2 different ways and got the same answer, 36. How can you apply it for a different setup? If the base is 50, height is 25, how many square tiles do you think you may need?
You need 49 plus 40 plus 47 plus 45.
Yeah, 49 plus 40, is it 48 or 47, right?
47.
49, yeah. Okay, but then do
All the
you
way down
add,
to 1.
would you actually go on adding it? 49
No,
plus
I would just do 50 times
Hmm.
the amount of odd numbers between 49 and 1, which is 25.
Exactly. So that's what you already found from the height, right? 50 into 25. And then would that give the total number of square
6.
tiles in the triangle?
Yes.
Is it in the triangle 12 into 6, 72? Does 72 make up this triangle?
No.
So it will make up a parallelogram, not the
It has be a
triangle.
parallelogram, then we divide that by 2.
We
So
need
it's to 25 times 20, 25 squared.
Yeah, and that is 625. Right?
Yes.
So
or
isn't it interesting for us to, take a picture, do some observations, ask wonder questions, and then build up on this thinking that this is nothing but you found a pattern, you found how you can arrange the shapes to, come up with some interesting way, smarter way to find the answer for it, and also verifying it by actually using some geometry and the shape, the thing we observed, and not only that but extending it to a general formula kind of thing for any shapes that is made with this specific rule. Yeah. Are you able to enjoy this notice, wonder and think routine?
Yes.
I don't hear anything from you. Was it interesting?
Yes, ma'am.
Yes, ma'am.
Okay. So this is an interesting way that will help you see the things around you in a different perspective and not just go pass by, but then pay attention to and see, can you find some meaning in it? Can I ask some interesting question and develop new knowledge or apply your existing knowledge of some ratio or here in this case we use geometry and algebra. Yeah, so this is a very interesting way that you can think through things. So I had another picture, but then I think we may not be have enough time for it, but then let's go to the balls in the bowl activity. Yeah, Siddharth, what do you say?
Yes, I think maybe you can just show them the picture and
Yeah, yeah,
you
yeah,
send
okay.
it to me. I'll email it to them tonight.
Yeah, sure.
Uh,
Yeah, I have it here. Okay, this is another wonderful picture. um, it's a kind of a colorful mat or something that has been made, but rich picture that has so many interesting aspects to it, where you can see geometry, colors, patterns, numbers, and also
Alluded
some
to.
rules. Yeah.
Um,
So this activity you can think through, apply the similar notice, wonder, think routine. So you can write down many notice questions, right? Like many observations, but take few of them, which is very interesting that you can pursue asking through the wonder questions and finding like more meaning through thinking how to find the answers. Yeah, but then do note down many of the observations that you can think of, like we did now, and then select few and go further. Okay, I think Siddharth will be sending you this picture.
yes,
Uh,
they can
yeah,
respond and
I
share
think,
their observations.
yeah, because we have a very interesting activity of game of unknowns for you all, right? So, which I'm sure you will all enjoy a lot. Okay, so here we go. I think Siddharth, we have around 25 participants. Shall we make it as groups of 5 so that they can, yeah?
Yeah.
Okay. Okay, so I hope you all have some 3 different bowls, right? If I can name it like, the red, blue, and yeah, so if I have it here, the red one, blue one, and the green one. Okay, so I have 15 balls, and so you all have. I have placed this balls in the bowls like this pattern, like 2 in red, 8 in blue, and 5 in green. And I'm asking you a question,
Okay.
like I kind of tell you,
Blues.
I kind of, yeah, Anushka, you having some question?
No.
Okay, yeah. So I'm actually going to tell, like, I want you all to find it out. Now I'm showing it, but then think that I'm having in my table with these not known to you. And I'll say a statement telling how children, I'm having 15 grains, okay? And then the blue bowl is having 6 more than the red bowl. Okay, 6 more than the red bowl, the blue bowl, and then the blue bowl is also having 3 more than the green bowl. Can you all find how many grains I have put in the red, blue, and green bowl? Okay, so this is an activity where we are all going to make this kind of a setup and ask these questions, like frame these statements so that the other team can find them. For example, let's say, can anyone tell, like, assume that you don't know this is 2, 8, and 5. And if I just say
That
only
is
these,
not possible to find out unless you know the total amount of balls.
yeah, the total amount of the balls, all of you know, you have only 15 balls, right?
Yes.
All of you have 15 balls. And if I just say that blue is having 6 more than red, and blue is also having 3 more than green, would it be possible for you to find how many balls are there in each of them?
Yes.
How do you find it? Can you tell Arav?
There's some algebra needed, so you can try.
Okay, yeah. Let's do the try and yeah.
Ma'am,
Yeah.
Say,
we can start by setting the blue ball by a number. and then we can, from that we can check with the other two, and if we will check if the sum is
Okay.
15. If not,
So,
that is out.
Yes,
okay, okay.
there need to
Yeah,
be
let's start doing it. Let's start doing it with the number. Anushka, what number do you think we can have?
It has to be more than 6, so let's do 7. Let's start with 7.
Okay, 7. But then think, blue bowl has 6 more than red bowl. So
So
what does
that means red ball has 1
Hmm,
and green ball has 4.
4? Okay. Now, does it add up to 15?
No.
No. So
So
what does it
it's
add up to?
out. It
It
adds up to 12.
12. So how do you then rearrange it to get a amount of 15?
You can try and add one more to the blue balls.
Okay. How are you trying? Just add one more. Is there some logic behind it? That's a good clue. Since these numbers are small, you're just trying it out. But then see, apply some logic. Is there a possibility that you can see the difference between the actual number and the
You can
number?
add 1 to every single ball.
Why?
So that it remains the same balance, like blue ball still 6 greater than red and 3 greater than green, and it adds up to 15 because there's 3 more.
Okay, that's a good idea. So basically you have a rule setup and then you are keep on adding or decreasing so that you get the whatever you expect, you get it. Yeah. Good. Then shall we we'll break it out into rooms, but then before that I want you to in each group you will actually use this as your thing. So you are going to make a setup. Okay, just make a setup, write down in your paper so that you can share it with teams. You are going to make a setup where it is just enough to just say only one statement and others can find. Okay, here I have told two statements. I have told blue is having 6 more than red and blue is having 3 more than green. So that I have given two rules or two statements for you to find. So in your new setup, you have to just think how you just need only one statement and that is enough for the other group to find the answer. Okay, so that will be a first setup. And the second setup will be a similar one where you can make any arrangement and form two statements. Okay, I hope you are all able to understand what does a statement mean. It means how you describe a bowl, the balls in the bowl. Yeah. So you need two statement at least to find the number of balls. Yeah, is that clear for all of you? Yes, any doubts here before we break out? You have, maybe shall we give 5 minutes?
Yeah, we can spend about 5-6 minutes in the breakout rooms, and I'll jump around between the breakout rooms and help in case you're stuck. So remember, at the end of it, we want you to have some of these mystery questions, right? That's you need to be able to give this challenge question to the other teams to solve at the end of your breakout room time.
Yeah. So at the end, other groups will actually find out your answer.
Actually, Siddharth sir.
Yes.
Can you enable whiteboards inside the breakout rooms?
Sure.
Whiteboards.
Think it's allowed. I'm just checking. Yeah, it's allowed. So everyone, please press the button to join your breakout room. Okay, please do join the breakout room. You would have gotten a notification to join the room. Please do that. Abhineet, you need to join in. I see room 4 has filled up. Ruhab, Kabir, Rashida, Garima, Syed, please do join the rooms. Welcome back from the breakout rooms. Please send your questions in the chat. And remember, you are trying to get different levels of difficulty from your questions. So let's try and do that.
I send it.
Okay, thanks, Aaron.
Yes.
Red has 4 more than blue and blue has 2 less than yellow.
Okay.
All
Right.
3 poles are multiples of 5.
Okay, I'm just copying. Oh, all 3 bowls are multiples of 5. Okay, I can also share my screen so that.
Yeah.
Can.
Red has 9 times of green, blue has 5 times of green.
Red has 9 times of green. Okay.
I have the answer for the 9 times one though.
Oh, okay. All 3 bowls have 5 is not a rule. You have already given the answer, right?
No.
He's answering the one that
Oh, okay. Yeah. Okay, then I'll remove it here.
Ma'am, I have the answer. Ma'am, I have the answer.
Okay. Yeah, fine.
Ma'am, can I say?
No, so does anyone have more questions? Because there were 5 groups, so we need at least 5 sets of questions. So far, we've gotten only 3.
Yeah.
Ma'am, can you move the screen back so we can see the questions again?
Yeah, just a minute. So are you not able to, I'm just writing down all your questions. You're not able to see?
No, not these, this thing, extension questions
I
and
wanted
all.
to know the extensions.
Okay. Yeah, just a minute. You're able to see my screen now?
Hold on a sec.
Okay. I'm actually sharing my screen, Siddharth. I'm not sure why. But it's not getting seen here.
I can see it, ma'am.
But you just need to move to the move.
Okay, yeah.
To the right so that the extension statements are visible.
Yeah.
6 questions. 6 questions. 6 questions.
You take a screenshot and solve it later.
I forgot them. I forgot to.
Okay.
Okay,
so
now I have a screenshot.
Okay, now I think most of you have made this interesting question of how to, maybe I'll just make this one come down so that, all of us can see both. Yeah. So these are your questions, right? And with one statement, what was the very obvious question that you all made? With just one statement.
Our question was all 3 bowls are multiples of 5.
So what would that be? Anyone, can you guess what can be the answer?
All
It's
of
very
them
simple.
are 5.
All of them are multiples of
5.
5, which is 5, right? So 5 plus 5 plus 5. Wonderful. Any other thing?
Ma'am, I think
there are some interesting patterns here that if you are
question 3 answer is red is 9,
No,
green is 1 and blue is 5.
Okay, for this one?
Yes.
Yeah? Okay, red is 5.
Red is 9. Red is 9, green is 1 and 5 blue is 5.
Okay, I think the 9 times itself will indicate that it should be only 1, isn't it?
Yep.
Yeah.
Yes.
Wonderful. Yeah, very good question. For this, there is something that for you to think at home. There is another thing that you can think for one statement. Can it be made of prime numbers? Think about it. How? Can it be made of consecutive numbers? Like, each bowl.
Yes,
So
it could be 4, 5, 6.
Okay,
Ma'am, it
you
can
should
be
not
3,
tell the
7
answer
and
now.
5.
So okay. So others, please do think. And then we have some other answer also right here. Okay, this one, red has, anyone able to find? Red has 5 more than blue and blue is 4 less than green. Okay, I think Arnav has applied a lot of algebra already to find the answers.
Oh, this is our question.
How would we go about with this? Red, blue, green? Any other team?
Ma'am, can I explain our question?
Okay, you can tell me. I'll jot it down for others to find.
Okay, so
We're going to have to wrap up soon because we're already on time.
Sure. Yeah.
I'm going to
Okay,
I
so
sent Arnav's question in the email to all of you. So all
Okay.
your questions that you put in the chat, I'll send it in the email so that you all have them. And
Sure.
I'm going to request Vidya ma'am to wrap up the session so that we can
Yeah.
talk a little bit after that as well.
Sure. So, Arnab, you can actually share it in the chat box and Siddharth will send to everyone to find the answers. So, these are some of the questions that will make you really think on, do we really need 3 statements to describe these 3 bows, or is it enough? What could be the minimum statement you need or the maximum statement you need to describe so that others can find it out? So, these things which you have done now through an activity can be actually applied easily through algebra in a intuitive way, where you can understand how many variables or the things that you used R, B, G are basically variables. Like you can have different values for them, right? So how these can be made so that you just need one statement, one rule, or 2 rules, or 3 rules. So
I got
we'll
the
be
answer
discussing.
I got the answer for the fourth
Yeah,
question.
so you all can share your answers for all these questions to Siddharth in his email, and we can have a very interesting discussion in the upcoming course that Siddharth will be explaining now. And I hope you all had a very good time playing around and then having this notice wonder think routine. I think this can be applied in detail in our upcoming course, and Siddharth, you can take it further.
Sure. Great. Thank you so much, Vidya. This was a lot of fun. I learned a lot doing it, though I didn't have the bowls. And especially the triangle, I really loved it because I ended up sitting and noticing patterns and deriving things for myself. And I realized that the sum of the first n natural numbers is n squared. Sorry, n odd numbers is n squared and stuff like that. So I really love being a part of doing these things on Gifted World because I learn a lot. So it's fun to be a student in these sessions. So thank you all for all your participation today. Right. So as Vidya said, we are hosting, and I mentioned earlier, we are hosting a summer program online in July. So it starts 3 weeks from now. And so and in case your parents are around, you can tell them about this. I will send details in an email as well. You all know, like many of you over here are very interested in math or very good at what you do. It's often difficult to find other people who operate at the same level as you, right, in your surroundings. And so getting together a group of very smart, very motivated people enables all of you to learn a lot faster and to push each other in a good way, right? So at Gifted World, we believe in, and GenWise, we believe in non-competitive learning, right? We don't want, this is not competitive exams. This is not that one person gets the first rank, everyone else is not good, right? We believe in learning through fun, as I said earlier. So this summer program that is happening in July, I'll just share my screen so that I can show you about it. We are specifically having a course on algebra. Last year, some of you attended courses that we held in August and September that you got access through the asset talent search. That time we did a pre-algebra course. This time Vidya ma'am will be running an algebra course where you'll get to do this work of patterns, where algebra is not just X and Y's and Z's that you put out there, but they help you see and understand patterns that are there around in the world around you. So this July, we're having an online summer program. For a decade now, GenWise has been running residential summer programs that happen in Manipal in Karnataka, where a group of students like you come together for 15 days or 21 days and really just go at it, having really fun learning stuff. This past May, students built submarines. They were learning generative AI. They were learning neuroscience. The students in grade 6 and 7 were doing carpentry and learning a whole load of really fun math, science, and physics. So this summer program is happening from July 7th to August 2nd. And we have a range of different courses for different age groups. Since you're all in the younger age bracket, the algebra course is the one that Vidya ma'am will be running. And in case you're interested, I'm just putting up a poll that you can fill out. I'll continue talking about the session while you're filling out the poll. That way we can reach out to you and share details of the course. Okay. So the idea of this program is you'd basically be meeting for 6 hours a week, right? So the algebra course runs from 3 to 5 p.m. Dubai time, Mondays, Wednesdays, and Fridays. So you'd meet for 2 hours, similar to this session, right? It'll be longer. This session was only about an hour and 10 minutes of content, right? So you'd meet for 2 hours, then you'd have homework and other things to do until the next session. And our goal, which we explicitly say, is that we want all of you to be challenged. If you're finding something that I can solve it, we're going to have the next level of question and the next level of question and the next level of question, so that you are really working at the full extent of what is challenging you, right? Because that's where you grow. And it's very difficult for schools to cater to this, right? Because in school, you're one among 40 people, right? Or 20 people in a class. Whereas here, we've gotten all the top students from all across the UAE together into this session. So you're really able to push each other. Anushka, Maharshi have all been part of previous courses that we've run at Gifted World. And Aaron is already joining this algebra course. So we're very excited to have all of you here. So along with algebra, for the junior students, we also have a course on inquiry, which is which is being taught by really lovely educators on how do you do experiments, not just what's there on a textbook, but how do you create your own, answer your own questions. I will be teaching a course on called Potential to Projectile, the physics of ancient arms. So we'll be using, Anushka has already done some of this, and I think Kabir as well. We'll be diving into the idea of learning levers, pulleys, simple machines, but not the textbook way. We'll be learning it by thinking about weapons and medieval weapons. So not because we like violence, but because there are particular things that make it fun. And then Rupin Cheda, who is an amazing, amazing person and engineer, is going to be teaching a course on computational thinking called Algorithm Adventurers. That's also for this age group. So do fill out the expression of interest in case you're interested. We'll reach out to you and tell you more about it. So
should I also fill it?
Wait, Aaron, no need, don't worry. I've been chatting with your mom about it.
Okay.
You're already in, so no worries. Yeah. So with that, I think we are a community. We really want you to be with us through the year. Such masterclasses like this keep happening. I know Krishana, Anushka, Kabir, Maharshi, Syed, you've all been part of previous sessions and continue to. We'd really love to see you continuing to engage with us through the year. Do tell your friends, right? We are open to anyone to join. Some courses have prerequisites, obviously, but we'd love to see you all here. And I'd personally like to hear, what are your thoughts? What are your reactions to the class that you've seen so far? Anyone has feedback?
It's really good. It's really good.
Sir, about the competition.
Vidya ma'am is a good teacher.
Last time when I went to the award ceremony, that time there was this executive came to and he was speaking about how competition thinking works, systematic thinking like that. So it's interesting to see that there's a course on it now. Like that.
Yeah. So, and this computational thinking course is going to be a lot of fun because Rupin is very clear. He doesn't want you to use computers. He wants you to use pen and paper. So learn computational thinking by pen and paper. Whether you know Python, whether you know how to program, there's still more to learn, because the way of thinking is best done with pen and paper, not with a computer. Once you can do it with pen and paper, then what you do on a computer will be far more powerful.
So I actually closed the poll thing. So how do I get it back?
Jagat, Sean?
No, it's me.
Just send me a private message in the chat. I will reach out to you. Don't worry.
Okay, sure. So should I tell what's my area of interest?
Yes, you just send me a chat message with your area of interest. I'll reach out to you, Jagat. Thank you. Anyone else has feedback for Vidya ma'am? Like, let's see, she's looking so sad because nobody's saying anything for her.
Thank you, ma'am. This session has been really, fun, and I learned like to look at something and then think about more than just what you can see, like thinking about the patterns and then the shapes inside and how to count things.
Yeah, exactly. You have such a wonderful room, I think. I could see it. So you find so many patterns already in your room, which you can notice, wonder, and think. Thank you, Krishan.
Ma'am. So thank you so much, Vidya ma'am, for teaching us. As you have taught me that looking at one thing, you can find out how deep it can be, how detailed it can be, but it can look so simple.
Yes, exactly.
That can be so simple.
Yes, exactly. I'm very happy to know that, it is inspiring all of you and you're all going to think like mathematicians, right? So not just go pass by, but then pay more attention, find meaning, and then deeper meaning, like Rajveer you told.
Ma'am?
Thank you.
Yeah.
Ma'am? You showed me that, honestly, for the pyramid thing, the first thing and only thing I thought about was the pyramid behind and the box on top. But you showed me that there's so much more to just the sector of math inside a structure in everyday life, to be honest.
Yes, exactly, Arnav. I'm happy that, it's inspiring many of you, and I'm really thinking that you're going to apply these in detail in our extended course.
Yes, definitely. Okay, so it's 8 o'clock now in India. So thank you all for joining in. Just wanted to, Anushka, also thank you for sharing your gratitude to Vidya ma'am and her session. And thank you, Harshita. That's very glad you're.
Yeah, very wonderful. So I'm really glad, I kind of, if it is helping you to think, see the world in a different lens, that what more than that? I'm very glad.
So M13, I still don't know your name. You're saying true, your dad says the same, but I don't know your name. And Ivan, grade 4, yes, you're welcome. Folks who are in grade 4 who are advanced are welcome to join in our sessions. No issues.
Okay, sir. Sir, excuse me, sir.
Yes.
I've sent it in the chat.
Yes, thanks, Jagat. I saw it. Okay.
Thank you, sir.
Thanks everyone for joining in today. Very glad to have you all.
Thank you, sir.
Yes, and you can just unmute, turn on your video, say bye, and we'll see you around when we're having our next session.
Bye, sir.
Bye.
Bye.
Bye, sir.
Bye, sir.
Bye, sir.
Thank you.
Bye,
Bye, sir. Bye, ma'am.
Bye, sir. Bye,
Bye,
ma'am.
Bye, sir.
everyone.
Bye, sir.
Bye, sir.
Thank you for the session. Bye, ma'am.
Bye.
Thank you for the session.
Bye,
Thank you,
sir.
Anushka.
Bye. Bye.
Say
Next time.
Bye-bye.
bye. Bye.